Hey everyone. So in the last video, we covered basics of the constructor and what are different kinds of constructor and how can we make use of them. Now in today's video, we are going to see how the constructor behaves with the inheritance. So let us start. If a base class has no default constructor, then the derived class must initialize it. Let us say you have a base class and you have a derived class which is inheriting from the base class. Now, your base class does not contain a default constructor. Then, in that case, it is the responsibility of the derived class constructor to call the base class constructor. So, let us see this with an example. So, here we will start with hash include iostream using namespace std. Now, let us create a base class first, class base. Inside my base class, I'll leave it empty, or we can just create a default constructor base in the. Now let us create a derived class which inherits the base class. It publicly inherits the base class, and inside this we are going to have a constructor for the derived class. Now if I leave it empty and let us write the int main. Now inside int main, I'm going to create an object for my derived class, derived d, or let us say d1. Inside this, we are going to see out derived constructor. Here we are going to see out base constructor. Now let us try to compile this. Cd constructor. Now let us run it again. It compiled, and we can see the base class constructor was called, then the derived class constructor was called. Even though we did not write explicitly that we have to call the base class constructor. If I write this down, even then it will compile successfully and we will have the same output. But what if we have a parameterized constructor and we don't have the base constructor at all? Now you can see if a base class has a parameterized constructor, then it will not get a default constructor. So now if I'll try to compile it, we will get an error. And you can see that we are getting an error already in the Visual Studio that there is no matching function. Now if I'll just remove this like we did before, even then it is going to show us an error because we have to initialize the base class. It is the responsibility of the derived class to initialize it. Now I'll write down base and I'll pass some value. Now this will work absolutely fine. And we got the same output. So there is one more point that is very frequently asked in interviews is whether we can have a virtual constructor. Can I write a virtual keyword over here? No, it is not possible because constructors cannot be virtual. Why? Because constructor is the first function that is called once the memory is allocated to an object. So the initialization process is carried out by the constructor. Until the constructor is not completed, we cannot say that the object is completely created. And at that point of time, the virtual table does not exist in the memory. So because of that, the virtual constructor is not possible because we cannot make an entry in the virtual table when there is no virtual table itself. So that's why virtual constructors are not possible. But we can create a virtual destructor because at the time of destruction, virtual table will already be there. So we can have a virtual destructor. So I'll remove this. And now let us move on to some other concepts like how we can have a deleted or a defaulted constructor. So we have already seen that my base class could have a base and an empty parenthesis. This can be a default constructor. I can also have a default constructor by saying default. This is also possible. Again, this is both of these are the default constructors only. Now, I can also delete my constructor. Instead of writing default, I could have written delete. Now, this will delete my constructor. But you might be thinking, why would I delete my constructor? In this way, I can restrict the creation of any object of this class. So, in those areas, we require to delete the constructor. Where we want to control the creation and the deletion of certain class objects, at that time we use them. It is majorly used in singleton and factory patterns, where we actually control the creations. We want to monitor how many instances have been created, or whether we want to or we don't want to create any instance of your class. So in those areas, we use the delete and defaulted constructors. Now there is one more concept. Let us move back to our PDF. So we can create an object dynamically by using malloc and new. If we use malloc, then it allocates the memory to our object, but it does not call the constructor. Whereas if we use new, then it allocates the memory and then it calls the constructor as well. So in malloc, no initialization happens. In new, initialization happens because we are calling the constructor. So new is C++ style, whereas malloc is C style approach of allocating the memory. I have a complete separate video on malloc and new where we are going to deep dive in these concepts. So you can watch that video for a complete knowledge on malloc and new. So you can see here with an example that if we use malloc, the constructor is not called, whereas if we use new, then the constructor will be called. So that's the difference, main difference between malloc and new in terms of object creation. Now, in the previous video, we have also seen the explicit and implicit conversions. So let us again go back to example. Here we have seen that we have a constructor, parameterized constructor in a base class. So I could have written base b1, and inside this I can pass an argument 10. So this will create an object and it will call the parameterized constructor. But I could have also done base b1 or b2 equals to 10. To avoid this, I can use explicit keyword because this is less readable. The first line is much more readable, and we can understand that B1 object is being created and we are passing an argument inside B1 or the base class. So the initialization is going to happen. But in the second case, it is much harder to understand that we are just assigning an integer to our base class. So just by writing an explicit keyword, we can avoid this approach of initialization. So I'll just comment this out for now. Let us move on to the next concept, which is the constructor overloading. So we have already seen that we have multiple constructors in a class. We can have, and we already had this. Say, instead of deleting, I was having a default constructor, and along with that, I have a parameterized constructor as well. I could have also passed multiple arguments in a different constructor, say base, int val, int index, and inside this, I could have done some operation. So we can overload the constructor. Now let us say if we had a virtual function as well. So we'll be having virtual void foo, and let us say it's cout base class foo. And we are going to override here void foo cout derived class foo. Now, since we have a virtual function foo inside my base class, if I try to just call foo inside my constructor, and let us create an object base v2, and let us pass some dummy arguments into it, 20, 30. Now if I try to compile this, you can see the base class foo is called. So since it is virtual and we are calling it inside the base class, we can call a virtual function inside a constructor as well. So that is what we were looking into. Now, a constructor cannot throw an exception as well. If a constructor throws an exception, then in that case, the creation of the object will be marked as incomplete. So the destructor also cannot be called on that object. Destructor can only be called on a completely created object, not on partially created ones. So if the constructor fails somehow, then the destructor cannot be called. Now let us see some key points that can I make my base class constructor or any constructor as static? No, we cannot create a constructor as static because marking the constructor as static means that the constructor belongs to the class. But actually, it does not belong to the class, it belongs to the object. The constructor creates an object. So that's why we cannot make a constructor as static. Now, can we make a constructor inline? This is one of the most frequently asked interview questions. Can we make a constructor inline? Yes, we can make a constructor inline, but the point here is that we don't have to make it. It is already inline. Every function inside a class are by default inline. But the point is that the definition should be inside the class. So let us say if I have this default constructor over here, this is by default inline. Every function inside a class, they are by default inline so that it does not violate the ODR rule. Because say if you have defined a class inside a .h file and you try to include them in multiple CPP files, then in that case you can get an ODR violation, which is one definition rule. So it would have asked you to make them inline, but this rule does not apply for the classes because the functions inside the classes they are explicitly inline only. So you don't have to write inline keyword before these functions. But what happens if you do not have the definition inside the class? Let us say this was your base class constructor, default constructor, but you gave the definition outside, which is B, scope resolution, B, and now you left it empty. So this has to be the base. So this is the definition of the base class constructor, default constructor. So we can have this, but in this case, the constructor is not inline. To make it inline, you have to explicitly write the inline keyword before the function definition. Now the function is inline. So the point here is you can create an inline constructor and it is already there if you have the definition inside the class. But you cannot use static keyword and you cannot use virtual keyword before the constructor. So I hope you would have understood many critical points related to constructor and how they are used in inheritance. Do like and share the video. We'll be coming up with more OOPS concept and many tricky concepts which are asked in the interview. Thank you.